we want to solve this differential equation. And the first thing is to identify what type of differential equation it is. Here's my dy dx. The coefficient of dy dx and y are constants. In this case, both constants are equal to 1. So this is first degree with constant coefficients. So if we go back to the template for that particular scenario, our first step in the template is to find the homogeneous solution. So we've got to find YH. Now the homogeneous is just when this is equal to 0, so all we've got to do is to solve y dash plus y equals 0. We can replace y dash with dy dx and take the y over to the other side, so we got dy dx equals negative y. Now if we multiply both sides by dx and divide both sides by y, we'll get dy over y, so dividing both sides by y, and then we're going to multiply both sides by dx, so that dx will cancel. When we divide this by y, we'll get negative 1, and we'll multiplying by dx, we get dx. So now we can put an integral on both sides. The integral of 1 on y is ln y, and the integral of negative 1 with respect to x is just negative x and plus c. Take exponentials of both sides, and we get e to the ln y equals e to the minus x plus c. E to the ln y is just y, so this is our homogeneous solution, is equal to, that can be expressed as e to the minus x times e to the c. Now e to the c is a constant, so we can replace that by a letter, we'll call it a. So e to the c is equal to a, e to the minus x. So we've done the first part of our template, which is just finding the homogeneous solution. The second part of the template is to guess the particular solution, and that is done by looking at the right hand side, and we've got a table of guesses there. If it is sine of kx, now the k in this case is 2, the coefficient of x, the substitution is c sine kx plus d cos of kx. So we'll make y particular is equal to b sine 2x. Now that 2 is important. If this is a whatever number that is, has got to go down here. B sine 2x plus d cos of 2x. So we've had our guess at the particular solution. The next step is to find the derivative of that. So y dash of p will be equal to, find the derivative. Now we've got a chain rule going on here because it's the sine of 2x, so we've got to diff in and we get the 2, so it'll be 2b. Derivative of sine is cos. Now if we look at this, the derivative of cos is negative sine, so this is going to be negative, but once again we've got a chain rule situation going on here, so we've got to find the derivative of 2x, so it'll be 2d sine 2x. Okay, so that's the third step. Fourth step is to substitute yp and y dash of p back into the original equation up here. So instead of y dash, I can substitute in that, and instead of y, I can substitute that. That will allow us to work out these values of b and d. So doing the substitute, so sub for yp and y dash p in original equation. Alright, so we'll just have a final look before I move the page up. So we've got to substitute y dash p for there and y in there. And we get 2 b, so substituting for y dash, 2b cos 2x minus 2d sine 2x. So that's y dash. Now for yp, we've got b sine 2x plus d cos 2x. So that's y is equal to 5 sine 2x. Okay. What we could do here now is to rearrange that, and we could get all the causes together. So we've got a cos here and a cos there, and they're both cos 2x. So we've got 2b plus d. So we've got a 2b and a d times cos x using the distributive law. And then we can get the signs together. So we've got, I'll put a squiggly line here to show they're different. So we've got two sine 2x terms here. So we can put b minus 2d plus b minus 2d sine 2x equals 5 sine 2x. Okay, if we have a look at this equation now, just remember we're trying to find what a value for b and a value for d here. We've got one equation with a couple of unknowns, b and d here, but if we look, that we've got a term over here with sine 2x. This is a cos 2x, and this is the sine 2x. So that means that this value here must be equal to the coefficient there. So we've got b minus 2d is equal to 5. So we equate that with the 5. And there is no term on the right hand side that has a cos 2x. So therefore this must be equal to 0. So we've got 2b plus d must be equal to 0. A couple of ways you can solve this. One is to use simultaneous equations. If we multiply the second here, so we'll make that equation 1, that equation 2. So equation 2 multiplied by 2, if I multiply this by 2, I'm going to add this equation with whatever I get here. And so multiplying this by 2, I'll get plus 2d. So if I'm multiplying this by 2, I get 4b plus 2d must be equal to 0. Now because we manipulated equation 2, I'll call that 2a. And my next step, the reason I multiplied by 2 is that I knew when I added these two here now, the d's are going to go. So I'm going to add equation 1 plus 2a and add the b's together. 1b plus 4b is 5b. And as I hoped, when I add the d's, the coefficients minus 2 plus 2 will make that equal to 0. And we add the right-hand side equals 0. So b must be equal to 0. Oh, sorry, beg your pardon. When I add these two together, we get 5. So dividing both sides by 5, we get b equals 1. All right. My next step is to find out what... we've got b, so we need to find out what d is. You can substitute for b back in any one of those equations. Let's go in this one here. So sub in 1. And we've got b is equal to 1. So 1 minus 2d equals 5. Take the 2d over here and the 5 over there, and we'll get negative 4 equals 2d. Divide both sides by 2 and we get d equals negative 2. So that has now allowed us to work out what the particular values for b and d are. So we can say that yp must be equal to, and we set up here it was b sine 2x plus d cos 2x. So instead of b we can just write 1. So it's just equal to sine of 2x. Our d is negative 2, so that'll be minus 2 cos 2x. So the fifth step is to state the general solution. So you know y equals yh plus yp, and that is equal to, now yh, if we go right back up the top, yh is ae to the minus x, so it'll be ae to the minus x. So that's the homogeneous solution plus the particular plus sine 2x minus 2 cos 2x. Okay, now we are given some initial solution, a situation way up in the original one, up here, when we were told an initial condition is that when we put x equals 0, y must be equal to 1. So that will allow us to work out down here, if we put x equals 0, will that allow us to calculate what a is. So initial conditions are that y of 0 is equal to 1. So we've got 1, our value of y, and when we put 0 in for x, we get a e to the minus 0, anything raised to the power of 0 is 1, so that'll be just a plus, now the sine of 0 is equal to 0, so that'll be 0, and the cos of 0 is equal to 1 minus 2. So that'll give us a, take the minus 2 over the other side, that'll give us a equals 3. So now we can state the final solution to this differential equation, and it's y equals, instead of the a, we've got 3 e to the minus x plus sine of 2x minus 2 cos of 2x. Okay, now if you have time to verify your answer, there is no reason why you can't go back and find the derivative of that and substitute y dash and y, and when you work that out you should get 5 sine 2x. Okay, so let's just go back over it again. We've got a template here for solving these first order with constant coefficients. So it's nice here that the coefficient here is 1, the coefficient there is 1. Don't always get that. So we first find the homogeneous solution, and then we have a guess at yp using those table of guesses that we need to memorise. We find the first derivative of the particular solution, sub yp and y dash p, back in the original equation to find out our values of b and d, which we did. And we get b equals 1 and d equals negative 2. So that'll allow us to write down the particular solution with no b and d there. So then we write the general solution as the homogeneous solution plus the particular solution, and if there are initial conditions for this equation, it allows us to solve for a, and we write the general or the solution at the end.